So tutorial sheet 1, question 16, we've got to calculate the Fourier series of this function. So it's going from 0 to a and then back down to minus a, and it's a triangular waveform with time. So just as a reminder, giving you the equation of the Fourier series, and we've got to calculate the three Fourier coefficients. So the first one, which is the easy one, is a0. Well, a0, as we know, is the average value of the function. Well, just from observation, you can see that the function is above 0 at the same amount of time as it is below. So the average is 0. Also, we can look at this function and also decide that it's actually an odd function with time. So that means if it's an odd function, an is equal to 0. So that's because it's an odd function. So what we're left with calculating is bn. And because it's an odd function, we can write bn as such. So it's going to be twice the integral. And rather than integrating it from 0 to t, we can integrate it from half of that because it's an odd function. So we want integral from 0 to t over 2 of 2 over t f of t sine n omega naught t dt, and obviously the 2 is due to the fact that it's an odd function. So we need to determine first of all what f of t is. So f of t can be broken up into two regions. We're only interested in from 0 to t over 2 anyway, so we've got two functions, from 0 to t over 4 and from t over 4 to t over 2. So these are just straight line graphs, so y equals mx plus c type graphs. So we can write down what f of t is as a function of time. So f of t is equal to, we've worked out the gradient of this, it's going to be 4a over t, period, times t, and that's going to be over this time period here, and then f of t is going to equal minus 4a over t, so it's the same gradient but it's just a negative version, times t, and then obviously this curve is going to hit the 0 axis here, and that will occur at time 2a, and so that is from t over 4 is less than t, less than equal to t over 2. So now we can work out, we've got our function f of t, we can now work out bn. So I can write bn down, so that's going to be, looking at this, so we've got 4 over t of the integral of 0 to t over 4, first of all, because we're just looking at this integral, of 4a t over t sine n omega naught t dt. So that's the first bit. Then we've got 4 over t integral of t over 4 to t over 2 of our second function, which is minus 4a over t plus 2a times sine n omega naught t dt. So what I'm going to do now is I'm going to split this up into actually three integrals. So I'm going to expand this out. So what we get is we get 16a over t squared integral from 0 to t over 4 of t sine n omega naught t dt plus 4 over t integral of t over 4 to t over 2 of 2a sine n omega naught t dt minus this minus here, the integral of t over 4 to t over 2 of 4a over t sine and omega naught t dt. So if I write all this down, what we get is 16a over t squared integral from 0 to t over 4 of t sine n omega naught t dt plus 8a over t integral of t over 4 to t over 2 of sine n omega naught t dt minus 16a over t squared t over 4 t over 2 of t sine n omega naught t dt. So I've split this up into 3 integrals. This middle one is very, very simple. It's just the integration of sine, but we need to cope with these other 2 integrals, which are clearly integration by parts. So move to another piece of paper. So what we've got to ask ourselves is, how do we calculate if we've got an integration from a to b of t sine n omega naught t dt. So we've got to work out that integral. We've got to work out that integral twice, actually. So what I'm going to do, I'm going to use integration by parts, and I'm going to say that t I'm going to assign as u, and I'm going to assign sine of n omega naught t as dv by dt. And just reminding ourselves of what the integration by parts is, if we have the integral from a to b of u dv by dt with respect to time, that's equal to u v between the limits of a and b minus the integral of between a and b of v du by dt. So what we're saying was, well, u is equal to t, dv by dt is equal to sine n omega naught t. So that leads us to say that du by dt is 1 and v is minus cos n omega naught t divided by n omega naught. So we can say from this that the integral between a and b of t sine n omega naught t dt is equal to, I've put this into this equation, what we get is minus t cos n omega naught t over n omega naught between the limits of a and b minus the integral between a and b of minus cos n omega naught t dt over n omega naught. So if we work that out, so we've got minus t cos n omega naught t over n omega naught. And if we work out this integral, what we get is plus sine n omega naught t over n squared omega naught squared. And both of these are between the limits a and b. So now we've worked out how we can do this integral, which we need to do to work out what bn is. Now, because bn was 3 integrals, I'm going to split it up into 3 parts. So first of all, I'm going to work out what I'm going to call bn1. So we remind ourselves what that was. The first integral was 16a over t squared, the integral from 0 to t over 4 of t sine n omega naught t dt. Well, of course, now we know how to do this, because this is our integration by parts. So I'm just going to simply put this into the answer we've just worked out. So we've got 16a over t squared, which goes into minus t over 4 n omega naught, because remember our integration limit is t over 4, the top one, cos n 2 pi over t. So I'm going to start simplifying it, so taking omega naughts out, times t over 4 plus, now the reason I'm not, the lower limit is obviously 0, so put 0 into here, and obviously there is no lower limit, so we can ignore that one. So we get plus sine of n times 2 pi over t times t over 4 over n squared omega naught squared. And again, the lower limit is 0, so you put 0 into this part and you get nothing, you get 0. So that's what we get. So if we work this through, we get 16a over t squared. And if I start to cancel these numbers out and rearrange it, so I'm going to put the positive bit first, so what we get is sine n pi over 2 over n squared omega naught squared minus t cos n pi over 2 over 4 n omega naught. But we can simplify this a bit more, because we know what omega naught is. So we can put this in. So we've got 16a over t squared sine n pi over 2 over n squared 2 pi over t squared minus t cos n pi over 2 over 4 n times 2 pi over t. So if we rearrange all of this and we multiply it all out, what we get is that the final answer for bn1 is going to be 4a over n squared pi squared sine n pi over 2 minus 2a over n pi cos of n pi over 2. So that's the first bit, bn1. So bn2, well, this one was the relatively easy one, because that's an easy integral. So reminding ourselves of that, it's 8a over t integral from t over 4 to t over 2. Oh, and that's just an integration of sine, so that's easy. So what we get is 8a over t to minus cos n omega naught t over n omega naught between the limits t over 4 to t over 2. Well, if we put those limits in, what do we get? So we've got 8a over t. So we've got minus cos of n times 2 pi over t times t over 2. N omega naught. Well, because we've got a minus, this is going to end up being a plus on the for the lower limit. So we've got plus cos of n times 2 pi over t times t over 4 for the lower limit over n omega naught. Well, if we cancel these out, what do we get? We get 8a over n t omega naught. We can bring omega naught out. We get cos n pi by 2 minus cos of n pi. And again, we can get rid of this omega naught and replace it. And what do we get then? Well, if we get the whole thing, we've got 4a over n pi to cos n pi by 2 minus cos of n pi. So now we've worked out bn1 and bn2. So now we need to calculate what bn3 is, the third integral. So bn3 is, this time it's minus 16a over t squared, and now we're going from t over 4 to t over 2 of t sine n omega naught t dt. So this one starts to get quite long, so you have to be a bit careful with this. So we've got minus 16a over t squared. So using the integration by parts, what do we get? We get minus t over 2 n omega naught, because for the first limit, cos of n times 2 pi over t times t over 2. And because we've got a minus in here, so the t over 4 is going to end up being a plus. So we've got t over 4 n omega naught cos n times 2 pi over t times t over 4. That's the first bit. And then we've got plus sine of n times 2 pi over t times t over 2 over n squared omega naught squared. And we're also going to get, for the lower limit of that integral, we're going to get negative sine of n times 2 pi over t times t over 4 over n squared omega naught squared. So that's writing down, using the integration by parts that we've already derived, the full integral. So what we can start to do is start to cancel things out. So we got minus 16a over t squared into, got minus t over 2n times 2 pi over t cos of n pi plus t over 4n times 2 pi over t times cos of n pi by 2 plus sine of n pi over n squared times 2 pi over t all squared. And finally we've got the minus sine of n pi by 2 over n squared with that. So we're starting to simplify things a little bit. So we come to minus 16 over a minus 16a over t squared into t squared cos n pi minus there over 4 n pi plus t squared cos n pi by 2 over 8 n pi plus t squared sine n pi over 4n squared pi squared plus minus t squared sine n pi by 2 over 4n squared pi squared. And so what we can do is we can multiply all this out, so we've got all the individual terms. So what we end up getting is 4a over n pi cos of n pi minus 2a over n pi cos n pi by 2 minus 4a sine of n pi over n squared pi squared plus 4a sine n pi by 2 over n squared pi squared. So that's long-winded, but that's the third coefficient of Bn. So now what we need to do, we've worked out all three, we need to remember that we've got to get the total. So we've got Bn1 plus Bn2 plus Bn3. We've got to add them all together to get our final Bn, and this is where we need to be really careful because there are a lot of components. So Bn is going to be 4a sine of n pi by 2 over n squared pi squared minus 2a cos n pi by 2 over n pi plus 4a cos of n pi by 2 over n pi minus 4a cos of n pi over n pi minus 4a cos of n pi over n pi minus 2a cos of n pi by 2 over n pi minus 4a sine of n pi over n squared pi squared plus 4a sine of n pi by 2 over n squared pi squared. So it's a bit horrendous, but there we are. So it might look tricky, but various things start to cancel out. So you need to look at the common terms, like for instance the cos n pi by 2. So we've got a negative 2a over n pi we've got a positive 4 a over n pi, and we've got another negative 2. So we've got the negative 2 here, negative 2 here, and a positive 2. So the cos n pi is over 2 cancel each other out. And then we can go through that looking at all the common terms, and the vast majority of them cancel out, leaving only 8a sine of n pi by 2 over n squared pi squared minus 4a sine of n pi over n squared pi squared. Well, that's starting to look a little bit better, and even better is the fact that for all integer values of n, sine of n pi goes to 0. So that thing just disappears. So we're left with Bn is 8a sine of n pi by 2 over n squared pi squared. So it is rather complicated, but we do get to this final answer for Bn. But that's not the final answer of the question, because we still haven't written down what the actual Fourier series is. So we've got to just finish that off. So what first of all I'm going to do is rewrite down what B of n is. So B of n was 8a over n squared pi squared sine of n pi by 2. Well, this thing simplifies even more, because what can we say? Well, when n is even, we get that Bn is 0. So for all even values of n, B of n goes to 0. So we're only interested in the odd values. So B of n is equal to 8a over n squared pi squared, and it's either going to be a plus 1 or a minus 1. Sine's either going to be plus 1 or minus 1 for all odd values, and it's going to be a plus 1 when n equals a 1 or a 5, etc. And it's going to be a minus 1 when n is equal to 3 or a 7, etc. And with a bit of fancy maths, you can show that you can write B of n a bit more simply as 8a over n squared pi squared times minus 1 to the power of n minus 1 over 2. So for all odd values of n, you get the right value of B of n. So now we're almost done. We just got to write down what the final Fourier series is. Remembering that a0 was 0, an was 0, so we get that f of t is equal to 8a over pi squared. There's just the constants, and it's the sum. N is equal to 1, 3, 5, etc., 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 to infinity of minus 1 to the power n minus 1 over 2 over n squared times sine of n omega naught t. And that is the final answer.